If you get any maximization objective function, so you can use the simplex step. Definitely you can expect this problem for your examination. Simplex method is very simple concept. If you get any negative value in RHS, you just convert it into positive value by multiplying minus 1. So in simplex method, for converting the inequality into equality, we have to add the slack variables. Hello everyone, welcome back to my new session on Operation Research. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed about simplex method for maximization problem. So today I will continue the simplex method with minimization problem or different inequality constraints. So let's get started now. So here we have objective function and constraints. You just observe this. We have minimization, min z is equal to minus 2x1 plus x2. So in my previous session, I have discussed about maximization problem, but this is minimization problem. If you get any maximization objective function, so you can use the simplex step, but here you have a minimization with two constraints. If it is minimization, you need to convert it into maximization. That is the first step for minimization problem. I'll repeat, if you get a minimization objective function, so you have to convert that into maximization type. So how to convert this minimization into maximization type? By multiplying minus 1 to all the objective function sign. So here we have minimization is equal to minus 2x1 plus x2. I will multiply minus 1 to objective function. So min z is converted into max z dash. So z is converted into z dash, min is converted into max. If you get minimization, you have to convert this into maximization by multiplying minus 1. So, have multiplied minus 1 to the objective function. So, min z is converted into max z dash is equal to minus 1 into minus 2x1, it is plus 2x1, and plus x2 into minus 1, it is minus x2. So, now this is your objective function. So, using this objective function, we can proceed further. So, here we have two constraints, less than or equal to and less than or equal to only, and RHS also positive only. So, we can convert this inequality into equality by adding the slack variable. First, I will write the objective function max z dash is equal to 2x1 minus x2, and subject to constraints x1 plus 2x2 plus s1, I am adding the slack variable, is equal to 6, and 3x1 plus 2x2 plus s2 is equal to 12. So, now this is in a standard form, and here I am adding the two slack variables with 0 coefficient s1 and 0 s2. So, now you have to find the initial simplex table. Write all the basic variables x1, x2, s1, s2. So, coefficient of this x1 is 2. x2 is minus 1, s1 is 0, s2 is 0. So, we have to find the solution and ratio again. So, basic variables are s1 and s2 with 0 coefficient. So, write all the objective function of x1, 2, 1 and 0, 6 for equation number 1, and 3, 2, 0, 1 and 12 for equation number 2. Then find the Zj value. Zj value is always 0, and find the Cj minus Zj value. 2 minus 0, 2, minus 1, 0 and 0. Here you just check whether it is satisfying the optimality or not. I have positive value, so it is not satisfying the optimality, not satisfying the optimality condition. So, here we have to find the key row and key column. For proceeding further, we have to find the key row and key column. So here we have to select the maximum positive value. It comes under, so key column is x1. Using this key column, we can find the ratio 6 divided by 1 is equal to 6. 12 by 3 is 4. So out of this, we have to select the least positive value, it is 4. It comes under the row is S2. So this is my key row. So S2 is my leaving variable. S2 is leaving variable and X1 is entering variable. Leaving variable and entering variable. So here, what is the key element? Pivot element is 3 because it is common for both key row and key column. 3 is my key element. Key element is equal to 3. After this initial simplex table, we have to find the first iteration, iteration 1. So again, write the basic variables x1, x2, s1 and s2, solution and ratio. What are the objective function for x1 is -2, 1, 0 and 0. So here the entering variable is x1 and leaving variable is s2. In place of s2, I will write x1. x1 is my entering variable. This is s1, 0. What is the coefficient of x1? It is -2. So now find the key row and non-key row values. So this is key row. Using key element, we can find the new key row values. So 3, 2, 0, 1, 12. List all the key row values. 3, 2, 0, 1, 12. Key row. Key element is equal to 3. So key rows are 3, 2, 0, 1 and 12. So 3 by 3, key element is 3. 3 by 3, 1. It is 2 by 3, 0, 1 by 3 and 12 by 3 is 4. So 1, 2 by 3, 0, 1 by 3 and 4 is your new key row values. And find non-key row values. Non-key row values. So here in non-key row value we have 1, 2, 1, 0, 6. 1, 2, 1, 0, 6. So using key row and non-key row value we can find the new value. So here first value, old value is 1 and corresponding key column also 1 and key row is 3. I'll repeat, old value is 1, corresponding key column also 1 and key row is 3. So 1 minus 1 into 3 by 3. 1 minus 1 into 3 by 3. So 3 get cancelled, 1 minus 1 is equal to 0. And old value is 2, corresponding key column 1, key row is 2. So 2 minus 1 into 2 by 3. So old value is 2 minus corresponding key column 1, key row 2 by 3. It is 2 minus 2 by 3. 6 minus 2 by 3. It is 4 by 3. 4 by 3. And next value is 1. Old value 1 and corresponding key column 1. Key row is 0. So 1 minus 1 into 0 by 3. It is 1. And old value is 0. Corresponding key column 1. Key row is 1. Old value 0. Corresponding key column 1. Key row 1 by key element. So minus 1 by 3. Old value 6, corresponding key column 1, key row is 12. So 6 minus 1 into 12 by 3. 3 ones are 3 fours are 6 minus 4 is equal to 2. So my dear students, simplex method is very simple. You just understand the steps, easily you can score in simplex method. Definitely you can expect this problem for your examination. Simplex method is very simple concept. Easily you can find the key column, key row and key element, and you can find the new value. So here I got new values. I will find Zj. So 0 into any number is 0. Minus 2 into 1, minus 2. Minus 2 into 3, 2 by 3 is minus 4 by 3, 0, minus 2 by 3 and minus 8. I will find Cj minus Zj. Minus 2 is minus 4. So minus 1 minus 4 by 3, minus 4 by 3, take LCM, minus 3 minus 4 divided by 3, it is minus 7 by 3. So minus 7 by 3. 0 minus 0 and 0 minus of minus 2 by 3 is minus 2 by 3. We just cross verify this. Do we have any positive value? No positive value. We have negative, negative, 0 and negative. So it's satisfying the optimality condition. So it has optimality condition. So max z is equal to 8. Max z is equal to 8. And what is the value of x1? x1 is equal to 4. And x2 value is not there, s1 value is there. So x2 is equal to 0. And substitute the value to the objective function. Max z is equal to 2x1 minus x2. Max z is 8. So 2 into 4 minus 0, 8 is equal to 8. So LHS is equal to RHS. So it has feasible solution. So this is your minimization problem. Next problem. We have maximization problem, but in constraints, in RHS we have negative value. If you get any negative value in RHS, you just convert it into positive value by multiplying minus 1. So if you are multiplying by minus 1, we will convert it as x1 minus x2 plus 5x3 less than or equal to 6. So greater than or equal to will convert it into less than or equal to plus 6. So multiply this constraint by minus 1 because in RHS we have negative value. So what is the condition? In RHS value should be always positive. Then we can find inequality into equality. So here we have negative value, have converted this into positive value by multiplying minus 1. So now you can find the solution. So again, max z is equal to x1, x2, x2 plus x3 and subject to constraints 2x1 plus x2 minus x3 plus s1. I am adding slack variable and again the final value is x1 minus x2 plus 5x3 plus s2 is equal to 6 and 4x1 plus x2 plus x3 plus s3 is equal to 6. So now I will add slack variable 0s1, 0s2 and 0s3. So now it is in a standard form. So now we can proceed initial simplex table. As usual, just write the coefficient of objective function, that is 1, 2, 1, 0, 0, 0 and the coefficient of and the basic variables x1, x2, x3, s1, s2 and s3. Now we have s1 slack variable, s2 and s3. Coefficients are 0, 0 and 0. Just write the coefficient of equation number 1, equation number 2 and equation number 3. Then find this Zj value and Cj minus Zj value. You just check whether this value is satisfying the optimality condition or not. If it is not satisfying, you can move further. You just find the next iteration, iteration number 1. So in the next iteration also you have to find the new values and whether this value is satisfying the optimality or not. I'll write the coefficient of this x1. x1 is 2 in equation number 1. 1 minus 1 is 1 and 0 and 0. Solution and ratio. Solution is 2. And in equation number 2, 1 minus 1, 5. S1 is 0, S2 is 1, 0. And solution is 6. And equation number 3, 4, 1, 1, 0, 0, 1. And solution is 6. Now find Zj value. It is 0, 0, 0, 0, 0. So what is Cj minus Zj? 1 minus 0, 1, 2 minus 0, 2, 1 minus 0, 0, 0, 0. Here we have all the values are positive only. So this is not satisfying the optimality condition. So here the maximum value is 2. Using this maximum value, I can find the key column. This 2 comes under the column called x2. So this is my key column. So key column is x2. This is my key column. And using this key column, you can find the ratio. So 2 by 1. Solution is 2. 2 by 1 is 2. And 6 by minus 1 is equal to minus 6. And 6 by 1 is equal to 6. So here we have negative value. You have to select the least positive value in ratio for selecting the key row. So least positive value is 2. I will select this is my key row. So S1 is my leaving variable. S1 is my leaving variable. And entering variable is x2. So now find the key element. So common for both key column and key row is 1. Key element is equal to 1. Key element is 1. So now we can find the next iteration called iteration number 1. So first iteration, again write the coefficient 1, 2, 1, 0, 0 and 0, x1, s1, s2, s3, solution and ratio. So here the entering variable is x2. In place of s1, I'll write x2. s2 coefficient is 2 and s2 coefficient is 0, s3 coefficient is 0. So using this key row and non-key row, we can find the new value. So key row is, this is key row, s1 is key row. So using this key row, I can find the non-key row values. So list all the key row values. 2, 1, minus 1, 1, 0, 0, 2. 2, 1, minus 1, 1, 0, 0, 2. So key element is 1. So here key element is 1. So what is the formula for finding the key row? Old value divided by key element. It is 2. 1 by 1, minus 1 by 1, 1 by 1, 0 by 1, 0 by 1, 2 by 1 is 2. So I'll write the new values 2, 1, minus 1, 1, 0, 0, 2. This is my new key row values. So using non-key rows, we can find the new values. Here, old value is 1, corresponding key column is minus 1 and corresponding key row is 2. I'll repeat, old value is 1, corresponding key column is minus 1 and key row is 2 and key element is 1. So you'll get 3. And old value is minus 1, corresponding key column also minus 1. Minus 1 is common for all the values and corresponding key row is 1. You will get 0. And old value is 5, corresponding key column minus 1, key row is minus 1. So you will get 4. And old value is 0, corresponding key column is minus 1 and key row is 1. So you will get 1. And old value is 1, corresponding key column is minus 1, key row is 0 and key element is 1. So you will get again 1. And old value is 0, corresponding key column is minus 1 and key row is 0. So you will get 0. and old value is 6, corresponding key column is -1 and corresponding key row is 2 divided by key element 1. So you will get 8. So now find out S3 column. Old value is 4, corresponding key column is 1. Old value is 4, corresponding key column 1 and key row is 1 divided by key element. You will get 2. And old value is 1, corresponding key column also 1 and key row is -1. You will get 0. And old value is 1, corresponding key column is 1 and key row is 5. Answer is 2. And old value is 0, corresponding key column 1, key row is 0. Answer is -1. And old value is 0, corresponding key column 1, key row is 1. Answer is 0. And old value 1, corresponding key column 1, key row is 0. Answer is 1. And old value is 6, corresponding key column 1, key row is 6. So answer is 0. So now you can find Zj value. Multiply this. 0 into any number is 0 and 2 into 2, 4. 2 minus 2, 2, 0, 0 and 2 2s are 4. Now we can find Cj minus Zj. 1 minus 4 minus 3. 1 minus of minus 2 is 3. 0 minus 2, 0 and 0. So here again I got positive value. So it is not satisfying the optimality condition. Again I have to proceed further. So maximum value is +3. So it comes under x3 column. So this is my key column for iteration 2. So key column is x3. So x3 is my entering variable. Entering variable is x3. And now find the ratio value. 2 by -1, it is -2. 8 by 4, 2. 0 by 2, it is 0. So here you have to find, here you have to select the least positive value, that is 2. So this is my key row. So 2 comes under S2. So S2 is my leaving variable. Leaving variable is S2. Entering variable is x3. So now key element is 4. Key element is equal to 4. Common for both key row and key column is 4. So now you can find the second iteration because this is not satisfying the optimality condition. So now you can find the second iteration, iteration number 2. So definitely in second iteration you will get the optimality solution. So this is about your maximization and minimization simplex method. So in simplex method, for converting the inequality into equality, we have to add the slack variables. And the first step is convert all the inequalities into equality by adding the slack variable, and next find the initial simplex table. So after that you have to find the key column and key element. Then we can find whether it is satisfying the optimality condition or not. So this is about your simplex method. So in my next session, I will come with a new concept called Big M method. Thank you.